Today's subject is programming and using a modern CNC lathe. This is Heinz Puts, and if you have any questions, call this number please. It's 614-888-8466. Hi, I'm Heinz Puts, Center for CNC, and first thing we'll do is let's take a look at the basic components of a CNC lathe. And the first thing that will strike you is they really don't look any different than the components of a manual machine. We have a headstock, we have a chuck. Normally in this case it's a hydraulic chuck. In industries most of the chucks are hydraulic. They could also be an air chuck or they could be a manual chuck, but normally it is a hydraulic chuck. We have a tailstock in case we want to make shaft type parts. It's usually also hydraulic. And we have a tool holding device, a tool turret. Now when you look at this looks pretty much like the components of a manual machine tool. As a matter of fact, what's interesting that these basic components haven't changed for at least 500 years, ever since somebody built the first turning machine. The first lathe looked pretty much like this, so that part of it really hasn't changed, except this is now driven by motors. So we have a chuck, power chuck. We usually have a power tailstock, and then we have a tool turret here. We could have from as few as 8 up to possibly 16 tools right here. And we ask for a tool number. This will index around. This is a motor on this side, and right in here is something called a curvic coupling, a positioning device. It's a ring gear. This will rotate around and then seat itself back into this ring gear quite accurately. The normal setup is that we have a turret in the rear. You could also see a lathe that would have a turret in the front, but most of the time the tools will all be in the rear. We could also have a combination of a rear and a front turret. Now let's take a look and see what that would look like. This is a typical medium-sized CNC lathe today. This is about 15 horsepower. This is a hydraulic chuck. It's variable speed. The turret holds about 12 tools. There's a foot pedal that would open and close the chuck. There's a switch that would move the tailstock in and out. Of course, you can select your tools by tool number. Sliding door. The machine is usually completely covered. Window is protected by iron bars. There's no lathe, there's a lot of centrifugal force, and you have to be very careful. In manual operation, there would be variable speed. Any speed within the speed range is available. You can manually select any of the turret tools. You'll notice the machine goes either one station at a time or all the way around to the tool without stopping. That's a typical modern setup. It also goes in both directions. That's called bidirectional index. The tailstock quill can be moved in and out. there's a push button that would move it out, and you can set the pressure. Another push button would retract it. So your basic three components are that you have a chuck, and you can normally select the spindle speed for this manually through an on-off button where you select forward and reverse. But that's not always true. You know, some machines you actually have to go through MDI to get the spindle started manual. But in most machines there is an on-off switch to actually start the spindle manually. There's normally, for a tailstock, there's either a foot pedal that brings the quill out and back in, or there could be a switch, also an in and out switch. Also, usually on the turret, we can index the turret through a selector switch. What we might have is a switch that looks something like this with numbers 1, 2, 3, etc. And we select a number and then push a button, and this will index around. You will notice that when this indexed, this curvic coupling, this ring gear, separated. Actually, this whole turret moves out a little bit. It comes out of this ring gear and then goes around through internal switches to select a tool number. Let's say that we want tool number 01 with offset number 1. We would have here, we would have the selector in number 1 position, push a button, and this would index around to the number 1 position. Turrets are usually built that we can have a selection of tools, of OD tools like this, plus ID tools. And we usually stagger those for purposes of limiting the interference, because normally boring bars stick out, and we have to be very careful that as we're turning that we're not actually running into this part. So that's the normal setup of a lathe, and now let's go on to something else. So let's take a look at the Fanuc 0 T control, and basically what we're looking at will also apply to the Fanuc 6T, the 10, 11, and really also as far as the control use is concerned, the principles will all apply to the milling machine, to the 0M control or the 6M control. To get a machine started, what we normally have to do, we have to be able to get our machine back to its zero return position. The zero return position in the X and also in the Z direction are internal switches at which point it picks up the coordinate system. The coordinate system would mean that it knows where the typical tool, typical number 1 tool is located. And in this particular case, it will be located somewhere around 8.5 inches. That will be the diameter that the control will actually pick up at that point. And then in this direction, the distance here from the finished face of the part to here is somewhere around 8.2. The numbers are not that round, they're really odd numbers, but what these numbers represent is that before we actually did this, we had set this up where we found out what these distances were. We know what this is and we know what this is. And somehow that's going to show up in our program later on. Now on this OT control, normally when we do a zero return, these numbers will actually be transferred into our readout. Here, these numbers will show up right there, and at that point the control will know what this is and also what this diameter is. So what you're going to see is how to start the machine, how to zero the machine, look at the different screens on the machine, the readout screen, the programming screen. And after we take a look at all that, we'll come back and we'll talk about this some more. To start the machine from scratch, there's usually a power switch at the back of the control or at the side of the control that has already been thrown on, so you can hear the hydraulic unit. What you do is you turn the control on. The control will come up by itself. It'll read its own information, and at some point it will appear like this. Now what we're going to have to do is we're going to have to zero the machine, and in order to do that we have to get the slides off their origin. You cannot zero if we're already at origin. So what we're going to do right now is switch over to the little handle and we'll move the slides off the origin. This handle is in one of the so-called handle positions. And in this handle we have a choice of moving either in the Z direction or in the X direction. We have to determine by using one of these buttons. Right now this button is, the X button is lit up. So when I crank this now in the minus direction, it will move down. The handle right now is moving in the minus direction, and the turret is moving off its zero position. Now I'll switch over to the Z direction and move it off in the Z direction. Now we're at a location where we can actually zero the machine. The selector switch is now moved to the zero return position. And to do the actual zero return, we will hold in the X positive button, and the machine will now zero itself. As we're zeroing, the numbers will change and the coordinate system will be picked up. This picked up the fact that this tool is sitting at 8.544 in relation to our coordinate system, and in the Z direction, at zero return, we will be 8 point something away from the face of our part. 8.2845. Now we are at zero. Zero is the absolute travel limit for this machine, and at that point it picks up the coordinate system. Now it knows where the tip of that tool is, and this happens to be our regular turning tool. The tip of that tool is sitting at these dimensions, which we have preset through our coordinate system. To be able to put any information into the machine at all, we have to be in our edit function on our selector switch. We are now in the edit function, and we can put information into the machine. We switch over to memory, we would be trying to run a part. We go over to the handle position. We have a selection of 1/10, 1,000, and 10,000ths per increment. Jog is jog, moving the machine. Rapid and zero return. But to get anything in there at all, we have to be in the edit position. At this point, we would have a choice of screens. Right now, we're in what's called a position screen, and the buttons here determine what screen we want to be in. This, for instance, is a programming screen, but in the position screen, we can see the absolute dimensions, or, as we page through this, we can see the incremental dimensions, or a combination of absolute and incremental dimensions. Normally, we work with our absolute dimensions. Now, as we go through these screens selectively, here's our program screen. This is our actual program, and as long as we're in the edit mode, we would now be able to cursor through this using the cursor key to go to different dimensions, the different points in our program. And in order to change anything at all, we would go to a particular spot in our program. I'm going to go to my spindle speed in service feet, and we're using 500 service feet. To change anything, the key, there's a lock key, has to be in the open position. Rewrite the value by saying S600. Right now the value is S500. And then there'll be a key that changes this around. We'll get to that later on. To continue with our screens, the offset screen would be our tool offsets, and we have a number of choices. We have what's called a wear offset, which would give us the ability to change part sizes. We also have a geometry offset that we use for setting up our tools in relation to one another. Are they longer? Are they shorter? And we have a work shift screen that sets up our coordinate system. So the offsets are very, very important. There's also a menu offset, but that option is not on this particular machine. There is a diagnostic screen. There is an alarm screen. There's an auxiliary graphic screen, which also isn't on this machine. And a macro. Macro is an option. Some of these things are options. But what we always have our position, we have our program, and we have our offsets to work with. And in the program screen, if we want to run a part, we flip over to memory. We will now be ready to run our part. And there are several screens in that. There's the program screen, there's the current, the next information coming up. There's a thing called a program check screen. Usually we run in program screen. So what you just saw is a Fanuc OT control, but you have to remember a lot of these things are options. You know, we could have a offset screen that only has a wear offset. This one had wear and geometry, and also coordinate setting. But the layout of the machine with the OT control could be all different ways. It depends on how a machine tool manufacturer actually buys this control. Now, the basic Fanuc control looks like this, but many things inside are options. It could be that you don't have a hand wheel. Possibly you have to find a position by actually using jog or something called incremental jog. Possibly you don't have these things. Possibly a machine has a separate button to start the hydraulic system. This particular machine, when you started to control, everything went on. But there are some machines that have a separate button for hydraulic system. There are machines that have a separate button for doing many different things. But you have to be flexible. I mean, you work with CNC machine tools, you have to be extremely flexible. And after a while, there aren't that many possible variations. So what you saw is that we did a zero return. We first moved off this position though, using the hand wheel. And the hand wheel will have an X and a Z position. I went into the X position on the hand wheel setting, cranked it off in the minus direction. This direction is the minus direction. So it was off the zero return. Then I switched over to the Z and I moved it off in this direction. This is the minus direction. Now we're off our zero return. Then I went to the selector switch that was marked zero return. And I initiated first the X direction, and it went to 0 in this direction and picked up this coordinate. Then I went to Z and it went in this direction and it picked up this length coordinate, which had been preset through this coordinate system setting. Now what we'll do is, let's take a look and see how we get information into the control. How to put information into the control, and then once that information is in there, how do we edit that information? Let's take a look how we get some of the information into the control. How do we put the information into the control? That would be writing a new program. First of all, our selector switch would have to be in the edit position, like it is right now. And some of these things apply to all Fanuc controls going back into the late 70s. They all had this type of selector switch. So we are in the edit position right now. The next really important thing is that the program number that we want to put in there can't be in there. So if we want to put in program number 0200, it can't be already in there. That would be an alarm of some kind. And here's what we have to work with. Here's our key selection. To put in program number O, the letter O200, we would actually touch the letter O, followed by the number 200. And then we have a selection of keys in the upper right hand side that says Alter, Insert, and Delete. Well, the selection here would be Insert. And if we take a look at our screen right now, program number 200 is now entered on our screen. Next thing we have to do is that at the end of each line we have to insert something called EOB, that's end of block, and we touch end of block and we insert that. Remember, the key is on the upper right hand side. Now if we look at our program this far, it says O200, there's a little sign behind it that designates the end of block, and the number 1 has come up by itself. Some controls are set by parameters that they generate block numbers all by themselves, and some are not. You actually have to write the lines. Now what we would do is we go back to our selection of inputs and we figure out what we would really like to put in there right now. The first line in the program is usually something like G50. So we touch the letter G, we touch the 50, and on some controls you have to insert one piece of information at a time, and on some controls you can write a whole line of information. Right now on the OT control, some controls again as an option have the ability to write a whole line and some don't. This particular one we can write a whole line, but I will still touch insert. And right now on our screen we would have N1 followed by G50. I've gone ahead and entered a number of lines of information, and I want to show you how you would get back to the beginning of a program. In order to change something or to adjust something, you go and touch the reset button. That's this red button right here. And the little cursor will flip over to the top, go back to the top, to the beginning of the program. Now to go through a program to change something, there are a number of different ways of doing it. One is to use the cursor and just step through the program. And each time you do this, it moves over one piece of information. And I will go forward here and go over to our spindle speed. Right now we'll be setting on the S value. This is S500. And what I would like to do is rewrite that into something else. I would like to have S600. So I'll just go back over to the S letter and I will write S600, which will appear at the bottom of the screen. And now right next to the insert button on the upper right hand side there was an alter button, which I will touch right now. And the number has been changed to 600 right now. So that's one of the ways of changing something. Another way would be now that I do something like this. I go back to the reset button right now and hit it. and what has happened is it has gone back up to the top. I can search down selectively. I can write the block number that I would like to search to. I would like to jump forward to block number 3. I will write that, N3. It shows up at the bottom of the screen. And again, the cursor down button, if you touch that, what has happened is that the program has jumped down to line number 3. Now you can use the cursor to move over to change something. I'm going to hit reset again now. And I would like to search to a code. What I'm going to do right now is I'd like to search to my first S code. I will touch the letter S, and the letter S will show up at the bottom of the screen, and by touching the cursor down button right now we'll jump to our first S, and there we are at S1200. So here are some of the things that we have to do to edit a program or to put a new program in. To edit or input, we have to be in the edit mode, and we have to have our key open. Some controls have a key, some controls don't have a key. It depends on the manufacturer. The manufacturer buys the control a certain way, and they may buy it with this option or they may not buy it with this option. So that would depend on your machine. And we have to have our program screen up. Now to put a new program in like we did, we had program number 0200. If we do that, we have to make sure that this program doesn't already exist. Because if it does exist, that would be an alarm. It will not take that. So we are in the edit mode, we have our key open, and we have our program screen up. And now we can selectively go to any part of the program. Let's say we would like to search forward N115. This is a long program with at least 115 blocks. So we would punch this in, and then we would use our cursor down key to jump forward to this point. Now one other thing we could possibly do, we could selectively jump to a code. Let's say that we have an X dimension in there of 3.05. If we only say go to the next X dimension, it would jump forward to just the next X dimension. But if we put an X dimension with an actual value, it will jump forward to that value. So now, let's take a look and see how we would apply this. We will run a part and we'll make some changes on that part through this editing process to improve the cycle time on this part. Let's make this program together. This is a finish cut only. The part's already roughed out. And it's a piece of mild steel, so we'll figure out a proper surface feet for this. We will use tool nose radius compensation. And then we'll actually see the part being made, and we'll improve the part. We'll change our tool offset. But first of all, let's, as a refresher, let's just go through this and we'll write this program together. First of all, we said this is mild steel. So suppose this is 1018 steel here.